If you've watched our previous videos, you know that we've been talking about something that I call pow-pow, which stood for the part outside the circle times the whole thing was equal to the part outside times the whole thing. It was a way that I used to remember what to do when I'm dealing with secants and tangents and to find out how long they are. So these two examples, nothing looks different at first. They look very similar to what we've just seen. However, we're going to see that these are actually those ones that do become a little more difficult as we start to involve the quadratic formula. So let's go ahead and set these up and see what's going to happen. So once again, if you've watched the last videos, you're used to this idea of drawing a bracket. I need to know how long this whole secant is. Well, if one piece is x and the other piece is 8, adding those together gets me the length of the whole thing. So x plus 8 is the whole secant. The other one, the blue segment, is a tangent that goes through and touches the circle once. So pow-pow tells me to do the part outside, which is x in this case, times the whole thing, which is x plus 8. Notice we didn't use that individual part inside. We never do. And then I'm going to set this equal to, for the tangent, we talked about tangent twice, do the tangent twice. The part outside the circle on the tangent is 16. But remember, the whole thing is also 16, so I use the tangent twice when I set these up. Part outside times the whole works every time. All right, let's go ahead and distribute, and you'll need to see why this one is a bit tougher than what we've looked at so far. Distributing the x into this first set of parentheses, I get x squared plus 8x. So it is quadratic again. We've dealt with some other ones that were quadratic, but the x squared ended up crossing out. In this case, I can see that that's not going to happen. I can't get rid of the x squared, so I'm finally going to have to deal with the fact that I have something quadratic, and it's going to take the quadratic formula to solve this. Using the quadratic formula means I need to be equal to 0. So my first step is going to be subtract that 256 so that I have everything equal to 0. So I'm going to have x squared plus 8x minus 256 equals 0. Now, if you have the program I gave you in class, this is not bad at all to do. You can use your program, the quad program, and find your values, or type in your values. A is 1, B is 8, and C is negative 256. If you don't have the quadratic formula, you're going to have to do the quadratic formula by hand, which isn't hard to do, but you're kind of in for a long, tedious problem. I'm going to go ahead and do that work at the end. I'm going to assume you have the program out there, and I'm just going to get the answers. However, if you want to see the work for the quadratic formula, go ahead and skip to the end of this video and I'll have my work pop up for that. Anyways, I went ahead and used the program already, and I found out that the two answers I got when I used the program were x could be negative 20.492, I think it was, or x could have been 12.492. So we'll get those same answers with the quadratic formula. It's doing it by hand. It's just a lot more work. Before I circle both answers though and say I'm done, we have to think back to what x stood for. X stood for the length of a segment, this piece of the secant outside the circle. It doesn't make sense to have a negative length, and so if you ever get a negative answer for these problems, you have to make sure you reject it. That answer is not going to work. The only answer that's going to make sense are positive answers. And like I said, if you want to see the actual work I did or could do by hand to get these answers, go ahead and skip to the end of the video and I'll show you that work real quick. All right, let's try one more example though together. So once again, I'm going to do pow-pow, the part outside times the whole thing. Well, the first thing I'll need then is to find the whole length of this segment. And I saw in class that some people had a hard time finding out what this whole length was. Remember, I'm adding these pieces together, so I need to add up 3 plus x plus 2. So I'm not distributing, I'm just adding up like terms. And so this whole segment is just going to be x plus 5. A lot of people had a hard time doing that. Just remember what we're doing. We're adding those pieces together right there. All right, a similar thing down here. I need to find this whole secant. So what I'm doing is x plus 1 plus x minus 1. And so plus 1 minus 1 crosses out, and x plus x is just 2x. Okay? So let's go ahead and set up our pow-pow equation. The part outside the circle of that upper secant is 3 times the whole thing, which is x plus 5, needs to be equal to the other part outside the circle, which is x plus 1, times the whole thing, which is 2x. So here's what I need to distribute and then solve from there. So distributing on the left isn't too bad. That's just 3x plus 15. Distributing on the right, 2x times x is 2x squared. So once again, there's my quadratic, and then 2x times 1 is positive 2x. Okay, so I'm going to need to use the quadratic formula, so I'll need to be equal to 0. So let's go ahead and subtract 3x. I want to keep the x squared positive, that's why I'm going to move things in the direction towards the right over there. I'll also subtract 15 from both sides. What that's going to leave me with is 0 equal to 2x squared minus 1x and then minus 15. So once again, I'm stuck using the quadratic formula, which if you have the program is not so bad. Without the program, you're in for a little bit of work. It's not going to kill you, but it is going to be a little bit annoying. So A is 2, B is -1, and C is -15. I'm going to assume you have the program so we can kind of wrap this part of the video up. Otherwise, stick around for the, I guess, bonus features. You can see me work this out by hand real quick. So using my program then, I get two answers. I get -2.5 and I get 3 as two answers. Remember, since x stood for a length of a side, any negative answer is not going to make sense. So I have to make sure I reject any negative answer. It's not going to work. The only answer this problem has is 3. And as promised, here are your bonus features, me working this problem out by hand. So you can see my work popping up here, doing the quadratic formula by hand. If you do have to do it this way, if you don't have the program, go ahead and try it. You can kind of check your work against my work. I'm not going to go through and explain every single thing I'm doing. There's an old video I've got about using the quadratic formula. If you want to watch that, you can search for it. Otherwise, that's how I found my two answers, not using the program.